In the last video lecture, we covered atomic structure introduction, and now we're going to learn some notation for how this information of how many protons, neutrons, and electrons get delineated or shown in kind of a shorthand. So we're going to learn what is called atomic notation and nuclear notation. So we have to learn a couple of vocabulary words before we can kind of do that. And so for atomic number is the number of protons in an atom. And it is important to note a couple things about atomic number. So one, this is found on your periodic table. And you'll see me abbreviate periodic table as PT. This is an identifying feature of matter. So it tells you what element it is. And so if we look on the periodic table, the one that I'm going to have you guys use is this one. And so if you don't have this downloaded or printed ideally, but if you don't have it, at least have it like saved on a tab or in your bookmark bar, somewhere easy to find. But if we look at hydrogen, okay, there's a lot of information in this box. And so you've got a few different numbers, okay? You've got the one above it, this 1.01, and this 2.1. And it's important to know what you should and shouldn't look for when you are getting information from the periodic table. So the number at the top, the 1, that is the same thing as it's the number of protons, it's the atomic number, okay? And you can kind of see that this right here tells you what is each part, but it's just good for you to kind of note that. So atomic number is something that's found on the periodic table. So every element has a set number of protons in the nucleus. Every element is different. That's why I say it's an identifying feature, meaning what makes hydrogen hydrogen is that it has one proton in the nucleus and no other atom on the periodic table has that. So like titanium has 22 protons in the nucleus, and that's what makes titanium titanium and no other element, and so on. And so all the way up through 118, 1 through 118 are the numbers on the periodic table. And hopefully you can see that the periodic table is arranged by increasing atomic number. So from left to right and from top to bottom, you can see that atomic number increases left to right and top to bottom, all the way to 118. The other numbers that are on the periodic table are useful more so in junior level chemistry, but not so much for us. So this average mass, just ignore it. You're not going to use it. And this electronegativity value is not something that you're going to pull. So the only number that you're going to pull from the periodic table in this class is that atomic number. So going back, too much. Okay, so the atomic number, it's an identifying feature, it's the number of protons, and on the periodic table, it's delineated on top of the element, okay? So on the periodic table, it's that top number, okay? You can find it on the periodic table, and that's what that one is. So mass number, all right? If we think about what makes up the mass of an atom, we should think of what are the heavy subatomic particles, okay? And hopefully you now know that the heavy subatomic particles are the protons and the neutrons of the atom. So mass number is literally the sum of those protons and neutrons. They're what make up the mass of the atom. And this is for one atom. Mass number is for one atom. If you notice on your periodic table, there is something that looks really, really, really close to mass number that a lot of students mix up, and that's average mass. But in averaging implies that you have more than one number. You can't have an average of 1. So we will talk about what this number is on the periodic table, but if we're looking at the mass of just one atom, we're not going to get that from the periodic table. So the periodic table is good for a lot of things, but it can't give us the mass of one atom. So mass number is not found on your periodic table. It's something that you either solve for or you are given it, okay? But it's not something that you look for on the periodic table. But when you think of mass number, think of heavy, okay? And what's heavy is the mass of the protons and the neutrons. Remember, you'd have to have over 1,800 electrons to equal the mass of one proton or one neutron, and so they don't contribute to the mass, so we don't include them when we're solving for mass number, okay? So atomic notation is a way to communicate how many protons, neutrons, and electrons there are in an atom in a shorthand form. And so these are examples of atomic notation. I'll do nuclear notation next. Okay, so what does the number behind the name tell us? So if we look at hydrogen 1 or lithium 7, and then sometimes students want to compare to what they see on the periodic table. And so they see hydrogen 1 up here, and then they see this 1.01. And then if you look at lithium, you see 3 here, and then you see 6.94. Remember, I told you not to use not look at this number, but a lot of students inevitably do, but you shouldn't, okay? 6.94 is a decimal versus I'm talking about 7 being a whole number. That's important. So the number behind the name tells us, it doesn't tell us the number of protons, otherwise it would have been hydrogen 1 and lithium 3, okay? But the number in atomic notation, it is telling you the element name, so element or element symbol, and then its dash mass number. And from that, you can actually deduce how many protons, electrons, and neutrons there are in an atom. So, let's see. If you have hydrogen 1, well, we know, so if I was asking you, well, how many protons, how many electrons, and how many neutrons are there? Well, for hydrogen, there's always one proton. That's what makes hydrogen hydrogen, okay? It has that little 1 up top. And since it's element mass number, and mass number is protons plus neutrons, well, they have to add up to 1. Well, the 1 is already from the protons. This means there's no neutrons, and usually hydrogen is just a proton, okay? There's no neutron in it. And then if we remember our a key understanding that all atoms are neutral, then however many protons we have to have the same number of electrons. So it should be 1, 1, 1. For this lithium 7, okay, if we look at lithium on the periodic table, it's atomic number 3. So that atomic number tells us how many protons there are. Electrons, all atoms are neutral, so there's 3. And then neutrons here, we have to solve for it, okay? And another way to do this is that mass number minus atomic number, the number of protons, equals neutrons. So if we take our mass number, which we have here of, we do it in this color, so we have 7 minus the 3, we should get 4. Or you can think about it, protons plus neutrons have to equal 7. So the 3 plus the 4 have to equal 7 there. So atomic notation, it's either the name -1 or it could just be the element symbol -1. So you could also see it lithium -3. Okay? And we already talked about all atoms are neutral. So what does that tell us? That the number of protons have to equal the number of electrons. Nuclear notation is similar, but it's a little bit different. So how do we write nuclear notation? So if you had atomic notation to kind of show you the similarities and differences. So nuclear notation, if you were given this and I said, okay, write the nuclear notation, you're going to write the symbol of the element. So you actually have to find it. Don't guess. Like if you guess N for neon, you're going to be wrong. Actually find neon on your periodic table. And if we go and find neon, we're going to see it's over here. And it has the symbol Ne versus nitrogen is N. So don't ever guess on the symbol. Sometimes people guess P for potassium, but potassium is K, and phosphorus is P. So again, just some common things. Always find the element, and the whole names are on there, so don't guess. So we're going to write nuclear notation. We're going to write the symbol of the element, so Ne. And then we're going to write the atomic number on the bottom left side of the symbol. Okay, so neon's atomic number was 10. We're going to write it here. Note that on the periodic table, it's above it, but nuclear notation puts it in the bottom left-hand corner. Okay, so this is the periodic table where it is, but for nuclear notation, bottom left. And then you're going to write the mass number, protons and neutrons, on the top left side of the symbol. And remember, mass number is something that you solve for or it's given. Okay, so you solve for it or it's given. And it's for one atom of neon. And we were given neon-19 here. I'm not sure if this is going to show actually because of where my video is, but I did have atomic notation of neon-19, and that -19 is the mass number. So we get to just write that up there. And this would be the nuclear notation. So you've got mass number on the upper left, and you've got atomic number on the bottom left. Okay, so that is the two notations that communicate how many protons, neutrons, and electrons are in an atom. And in the next video, I will do a couple practice problems to see if you can kind of put all of this together.